Class, this is Wednesday, May the 7th. No, it's Thursday. Sorry, Thursday, May the 8th. May the 7th, sorry. Thursday, May the 7th. Anyway, it's the end of the week. So here we go. We got a few easy ones for you. So question 20, convert 135 degrees to radians. And remember, pi is equal to 180. So whenever we convert to radians, it's always pi over 180. So looking at the 135 over 180, that just simplifies on the calculator, math enter to 3/4. So our answer is simply 3 pi over 4. Now it says, using the unit circle, evaluate sine 300. Well, we can remember that sine 300 is sine 300 minus 360, or sine minus 60. And if we look at our right half circle, we can see if we sweep down 60, then we're going to have a 60-30, and the top, or the base part of it, opposite to 30 is 1/2, but the opposite to 60 is negative square root of 3 over 2. Okay, so that's just for 60. So there it is in quadrant 4. It's just negative because it's in quadrant 4. Here's another easy one. Cosine inverse, remember second cosine, negative 1/2 is 120 degrees in degrees, and then it's times pi over 180 to get it to radians, and 120, or 12 over 18, simplifies to 2 over 3. So there we go again, 2 pi over 3. Now on this next one, they give you a graph of the equation. So they have a graph with something starting up at 0, 3 high, and then coming down to 0 at pi, and going back to the negative 3 at 2 pi. And on the other side, of course, it's symmetric, and cosine is the one that's symmetric and starts high at the top for 0. So notice how at negative pi it's at 0, just like it was at pi, and at negative 2 pi it's negative 3, just like it was at 2 pi. So from 3 to negative 3 is what we call an amplitude of 3, or an A in our equation, and the whole period is 4 pi, as shown below there. Just marking it out. Now for our equation, y equals a cosine bx, to get the b, we'll let the whole period be 4 pi equals 2 pi over b, because that's how we get our b. So multiplying 4 pi by b, and then we get equal 2 pi, then we divide both sides by 4 pi and get b equals 1/2. So our equation that they wanted from the graph that they gave us is y equals 3 cosine x over 2. And we can omit 24 and 25. That gets us halfway through the final exam pretest. Now here's the second 1 through 25. And for the first one here, it says find b in triangle ABC to the nearest tenth if angle A is 54, B is 39, and side A is 350 up here, okay? So that's what we're given. So now we want to find B, so we can use law of sines. B over sine 39 is equal to 350 over sine 54, and cross multiplying B equals 350 sine 39 over sine 54 comes out to approximately 272.3. Now for 27 or 2, you'll be seeing 2, but it's the 27th question. Use the figure to see exact values of sine alpha minus beta. So when we look at the triangle, we have the triangle AB with the C at the right angle. So the side little b is 6, and the side opposite C, the right angle, is 9. So we first have to find the side opposite angle A, or opposite alpha. So a squared plus 6 squared equals 9 squared, or a squared equals 9 squared minus 6 squared, which is 81 minus 36, and a squared equals 45, and a equals then the square root of 45, which, using perfect squares, the square root of 9 times the square root of 5 equals 3 squares of 5. So now we can get our sines and cosines of alpha and beta. So now sine alpha minus beta, which is what we wanted, is sine alpha cosine beta minus cosine alpha sine beta. Now looking at our alpha, the opposite to alpha is 3 squared roots of 5. The hypotenuse is 9. But the cosine of beta at the top is adjacent 3 squared roots of 5 over 9, so that's really that squared. And then we'll see it's going to happen for the second group. So cosine alpha is adjacent over hypotenuse 6 over 9, and sine b at the top is opposite, which is 6 over 9 again. So we have, when we multiply out, 3 times 3 is 9, times the square root of 5, square root of 5 is 5, minus 6 times 6, so that's 45 minus 36 over 81, or 9 over 81, or 1 over 9. Now this is 28, or you'll see it on your test as 3. So now we want to state primary solutions for 2 cosine x plus square root of 3 equals 0. So all we need to do is subtract square root of 3 over and then divide by 2. So cosine x equals negative square root of 3 over 2. Now looking at our triangles that we're making, we notice that negative square root of 3 over 2 will have 2 possibilities, because if we make it on the negative x-axis, which we'll use for the cosines, then we'll have 30 degrees, because opposite of 30 is a half, and opposite to 60, which would be left at top, would be the negative square root of 3, and so for the bottom triangle, which would be 180 plus 30. So we have 180 minus 30, or 150 for the top angle, and 180 plus 30 for the bottom angle. Now 150 times pi over 80 allows us to simplify 150 over 180, or 15 over 18, to 5 pi over 6. And 210 times pi over 180 is the same as 21 over 8, 7 pi over 6. So those would be the 2 primary ones. And then we would admit 29 or 4. Now here we're asked to simplify tangent times parentheses cotangent minus sine cosine. So tangent breaks up into sine over cosine, and cotangent, of course, is its reciprocal, cosine over sine. So multiplying tangent by cotangent should give us 1 because they're reciprocals. And indeed we can see that, having broken them down into sines and cosines. And then if we multiply tangent times minus sine cosine, we see minus sine cosine times sine over cosine, the tangent. The cosines cancel, and we have left 1 minus sine squared. Now going back over to our fundamental trig identity, sine squared plus cosine squared equals 1. Subtracting sine squared gives us cosine squared equals 1 minus sine squared, which is what we wanted. We simplified our whole expression now as cosine squared. Now for 6, we want to verify that sine 2x over 2 is cosine over cosecant. So sine 2x is given as 2 sine x cosine x. That's the formula for sine double x. And on the right side, we have cosine divided by the reciprocal of sine. So that's 1 over sine. So cosine divided by 1 over sine is cosine times sine, just like the left side is with the 2 canceled out, sine times cosine. So that's verified. Now 7 is going to be, well, we'll do the law of cosines on this one, it looks like. So yeah. So how far apart are Josh and Michael if Josh hiked 12 miles in a northwest direction, or 45 degrees is shown up from west, or straight left, and Michael hiked 15 miles, 30 degrees south of west. Now notice where the down 30 degrees is. That leg should be 15. I just didn't put it down there, but that's what our instructions are telling us. So notice what we have is we have 2 sides, 12 and 15, and the angle between them, which we can add up to 75, 45 plus 30. So this is an easy one now. D squared, or the total distance between them, is 15 squared plus 12 squared minus 2 times 12 times 15 times cosine 75. So we get an answer for that, and then square root it, and the square root of the top line, or the line above, becomes an answer to 1 decimal point of 16.6. And now we're asked, we have one just like this on the test, exactly like this. Classify each sequence. Well, the 1, 1, 2, 3, 5, 8 is known as the Fibonacci sequence, which has been around since Egyptian times and had renewed interest in it in the Mediterranean basin with the Islamics, and then came into Italy where the Renaissance was. But this has been something that's been used in so many things. You should look up Fibonacci on Google sometime and see all the things that are related to it. But anyway, this has a sequence term of recursive of a sub n. The current term is a sub n minus 1 plus a sub n minus 2. For instance, 2 is equal to the 1 plus 1, 3 is equal to the 1 plus 2, 5 is equal to the 2 plus 3, and so on like that. So now B is the sequence 1, negative 1, 1, negative 1, 1, negative 1. So this is an alternating sign pattern, and this simply is written as a to the n is equal to negative 1 to the n power, and that makes it geometric. Now C is 1, 3 halves, 2, 9 fourths, and 3. Well, it looks promising on the first two. So 1 plus 1 half is 3 halves, and 3 halves plus 1 half is 2. But 2 plus 1 fourth is 9 fourths, and 9 fourths plus 3 fourths is 3. So it's definitely not an arithmetic pattern, and it's no way it could be a geometric either. But on D, if we have 1, 1 half, 0, negative 1 half, negative 1, we see this is subtract by a half pattern. And so with an equals a1 plus n minus 1d would be our arithmetic sequence with d equals negative 1 half and a1 equals 1. Now on 9 here it says find 3 arithmetic means between 4 and 48. So what that means for us is we're going to write it out as 4, comma a2, comma a3, comma a4 equal comma 48. So now what we're going to use is the geometric sequence, the explicit one. A sub 5 equals a plus 1 plus 5 minus 1d. D is what we're trying to find. So our fifth one is 48, our first one is 4, and 5 minus 1 is 4d. So subtracting the 4 over, we get 44 is 4d. Dividing by 4, d is 11. So now, starting with a2, or a1 is equal to 4. So a2 is equal to 4 plus 11, or 15. a3 is equal to a2 plus 11, or 26. a4 is equal to a3, 26 plus 11, or 37. And a5, just to check, is 37 plus 11, 48, which is what we were told. Okay, and now for 10, write both a recursive and an explicit formula for the sequence 72, comma 108, comma 162, comma 243 on out. Well, we can see that you can't add because it keeps getting bigger and bigger. So we're going to try the geometric and see if 108 over 72, which simplifies on your math enter to 3 halves, is equal to 168 over 108, and that again should math enter to 3 halves is equal to 243 over 162, and indeed all three of those ratios, the next over the current is equal to 3 halves, which gives us a geometric sequence. Now the recursive form for that is an equals 3 halves times a sub n minus 1, or 3 halves times the last one. And the explicit form is an is equal to a1 r to the n minus 1, or 72, the first term, 3 halves to the r to the n minus 1 power. Now the summation from 1 to 10 of 3n minus 2 is, remember, we want the a1, which is easily found as 3 times 1 minus 2, or 1, and we want the last one, a10, equals 3 times 10 minus 2 is 28, so that we can now do the formula for the arithmetic sums. S sub 10 is equal to the total terms over 2, comma, the first plus the last term. So that gives us 5 times 29, or 145. Now, the infinite sequence from n equals 0 to infinity of 3 times 2/3 to the n, well, we need our A1 and we need our R. So R is clearly 2/3, but we want to make sure we get A right, the first term. So that's 3 2/3 to the 0, because n starts at 0. Well, 2/3 to the 0 is 1, so A is 3. So our formula for S infinity is A1, the first term, over 1 minus R, or 3 over 1 minus 2/3, which is 3 over 1/3, which was 3 times the reciprocal of 1/3 is 3 times 3 is 9. So that 3 times 1/3 is a misprint. It's 3 times 3 equals 9. And we're going to skip 13 and then do an easy one to finish for today. So how many ways can the first 4 spots in a batting order be filled using the 9 starting players on a baseball team? Well, here it clearly matters what order we're doing it in, because the different players would have, different starting lineups based on their abilities. So permutations are what we have to use. So the total 9 goes in front, and then P, and then the smaller amount out of the 9, 4. So this is 9P4, which is defined to be 9 factorial over 9 minus 5 factorial, or 5 factorial. Now looking over, we can see that the 5 factorials cancel. So we have 9 times 8 times 7 times 6, which comes out to 3024. And hey, we've only got 1 day, but since we're giving you Friday to catch up, we'll finish this pretest out on Monday, and then you'll have about 7 or 8 days to finish the final. God bless you, and we're almost home.